So welcome students. So in this question, we given a quadratic inequality x square minus 2x plus a square minus 6a should be less than 0 for all x belongs to 1 to 2. So if that is the case, a should belong to which interval? So if this has to be less than or equal to 0 for every x belongs to 1 comma 2. That means if I take the graph of this expression, if I take y is equal to this, its graph should be always less than or equal to 0 between 1 and 2. That means the graph has to be like this. Because the leading coefficient is positive, it is an upward parabola. So the graph has to be like this. That is, at x is equal to 1, it should be less than 0. At x is equal to 2 also it is less than 0. If at these two values the function is less than 0, then obviously it is negative between 1 and 2. So what is the condition that I need to apply? The condition that I need to apply is f of 1 should be less than or equal to 0 and f of 2 should also be less than or equal to 0. So if these two conditions are valid, then between 1 and 2 the function will be negative. So what is f of 1 less than 0? So 1 minus 2a plus a square minus 6a less than or equal to 0. That is, a square minus 8a plus 1 is less than or equal to 0. So a quadratic expression less than 0 implies a lies between the roots. So what are the roots of this? 8 plus or minus root of b square is 64 minus 4ac by 2a. That is equal to 8 plus or minus root 60 by 2. That is equal to 4 plus or minus root of 15. That means a has to belong to this interval. That is, a belongs to 4 minus root 15 to 4 plus root 15. So this is one part of the solution. So f of 1 less than 0 implies a has to belong to this. Now the second condition is f of 2 should also be less than 0. So if you take f of 2 is less than 0, you get 4 minus 4a plus a square minus 6a less than or equal to 0. That is, a square minus 10a plus 4 is less than or equal to 0. So again, quadratic expression less than 0, that means a lies between the roots. So what are the roots of this? 10 plus or minus root of 100 minus 16 by 2. That is equal to 10 plus or minus root of 84 by 2. That is equal to 5 plus or minus root of, so if I take a 4 common, you get 21. So now, for f of 1 to be less than 0, a has to belong to this. For f of 2 should be less than 0, a has to belong to this. Now both of these has to happen, then only the given condition is valid. So if both of them have to happen, I just need to go for the intersection of these two solutions. So now let me plot these two solutions on a number line. So one is 4 minus root 15, the other is 4 plus root 15. So what is 4 minus root 15? 4 minus root 15 is somewhere very close to 0 point something. This is a positive number, this is also a positive number. Now if I take, so my a has to belong to this interval. Now if I take 5 plus root 21 and 5 minus root 21, obviously 5 plus root 21 is more than 4 plus root 15. So 5 plus root 21. So where does 5 minus root 21 lie? So 5 minus root 21 is also very close to 0. Just need to find which of these two is bigger or smaller. That is, you should analyze whether 5 minus root 21 lies on the right side of 4 minus root 15 or left side of 4 minus root 15. So if you look at the values of 4 minus root 15, so root 15 is somewhere around 3.87, that is 3.9, somewhere around 3.9. So 4 minus root 15 is around 0.1. And root 21, if you observe, root 21 is around 4.6. So 5 minus 4.6 is around 0.4. So does 0.1 lie before or 0.4 lies before? Obviously 0.1 lies to the left side. So my 5 minus root 21 lies on the right side of 4 minus root 15. This value is around 0.1, this value is around 0.4. So now if you see, my first solution says that my A has to lie between these two. The second solution says that my A has to lie between these two values. So now what is a common solution to these two? My A has to lie between 5 minus root 21 to 4 plus root 15. So that will be the answer to this question. A belongs to 5 minus root 21 to 4 plus root 15. This will be the required interval for A. Thank you.